Okay. Hi students. I hope everybody is doing fine. Now in this video I am going to discuss the concept of distributed databases as well as why organization needed and what are the types of distributed databases. Now for the learning outcomes of this course, students are expected to first differentiate distributed and single node databases. Second, know the importance of distributed databases in computing. Third, learn the concept of two big paradigms or models of distributed databases. These are the big compute and the high availability. And lastly, to configure the master-slave streaming replication of a database. But to get as oriented in this course, let me talk a little bit of distributed database and single node database and see the differences of the two. Now, when we say distributed database, data are distributed across multiple computers. Now, as you can see in the figure, we have here multiple computers running and hosting databases. One computer hosting the master database where transactional data resides. Another computers that are hosting slave databases. Now, the idea or the concept of the implementation of this database is that it makes a copy of the master database and then distribute it across these slave databases. Now, the purpose of this implementation is that whenever the master database fails due to maybe hardware failure or network failure, transaction can still be completed because all data are available in the slave databases. Okay, so that's the concept of distributed. And among the distributed databases are the Google Spanner, we have the Azure Cosmos, and all data warehouses. Now, in contrast to distributed database is the single node database, where the entire database runs on a single computer. So as you can see in the figure, so we only have a single computer running and hosting the database server. The problem with this implementation is that whenever this system fails, transaction will be interrupted. So that's the problem. Okay, so that's the differences between the distributed and the single node databases. Okay. Now, lots of organization and business firm prefer to have distributed databases over single node database or databases. And in fact, many of them were already migrated to distributed databases. Now, the reason behind are the problems that they've encountered during its operation. And these are the common problems that they've encountered. First, first is a lot of data that need to store. So remember the implementation of a single node database, it only uses a single computer. So meaning it has a limited space. Now, second, computing of all the data takes a very long time. Of course, because it only has a single processor. The third one, whenever the database hardware fails, the whole system will go down, no? Then of course ang ilang solution is to buy, or why not buy big computers, more powerful computers. But buying big computers, meaning the more expensive it gets. So it is not ideal if your organization are just starting, or if you only have a small organization. So not a practical solution. Then we have here a terminology, a fault tolerance, which means if a database resides in a single computer and that computer goes down, then the application will go down for all users. So transaction will be interrupted. And the implementation of single node database is actually not a fault tolerance, because remember, the entire database resides on a single computer. So whenever the database or the system that hosted the database fails, the application will also fail for all users. So single node database is not a fault tolerance. Okay. So maunang nabuo ang concept sa distributed databases because of the problems encountered in the implementation of single node databases. So mo na siyang ideya sa distributed databases. Whenever the master database fails, transaction will still be completed because either of those slave databases pwede siyang mahimong master database, because data are available to that database. And if the second master database fails, then pwede na po ang isa na po mahimo ang master database. So that's the idea of distributed databases. Now, there are two types, or there are two paradigms or models of distributed databases: the big compute databases and the high availability databases. Now, for big compute databases, the data are split across different nodes, while the high availability, it makes a redundant copy of the full, it makes redundant copies of full data on different nodes. So later on the slides, ma-demonstrate ng big compute databases and high availability databases. Okay. Now for big compute databases, assuming that this is the master database, so what happens is that one third of the master database will be copied and distributed to slave, or to this first node, and the other one third will be distributed to the second node, and another one third will be distributed to the third node. So basically, ang entire data sa master database gibahin-bahin sa tulo ka node, no? One third sila. The problem with this implementation kaning big compute databases, although mas mapaspas siya because cluster ang pag-process niya, pero mahitabo whenever the master database fail, yes, the data can still be accessed because all data nga naa sa master database naaraman po daning tulo ka node, no? So bisan asa pwede, kung available ang tulo, then the transaction can still be completed, but whenever the master database fail and one of the node or one of the cluster will also fail, then dili na kumplito. Kaya mawala na ang 1/3 sa full nga data. So that's the problem of big compute database, although mas fast pa siya. Now, muli ang illustration on the big compute databases nga katulad ng part, no? So 1/3 of the master database distributed to the first node, 1/3 of the master database, another 1/3 distributed to the second node, and another 1/3 distributed to the third node. So muli dagway niya, no? Maori hapon ang mga data nagkalahi-lahi lang sila dito sa RD, but then pwede rin gihapon na siya makuha ng mga data, no? Okay, but then again, that's the problem of big compute database. Kaya kung whenever the master database fail and one of the node will also fail, then dili na kumpleto ang data. Okay, so unlike the high availability databases, ingon ana ang implementation. Now, assuming that this is the master database, ang mahitabo, kopyahon yung tibuok, then i-distribute sa first node, tibuok copy to second node, and tibuok copy to third node. So whenever the master database fail, and either of this node will also fail, makompleto yung palang transaction because all data are available in the second node. All data are available in the third node. So that is why they call it high availability, because the availability of data is high, no? So that's the concept of high availability. Okay. Now, one thing in dagway, excuse me. Now for high availability, one thing in dagway sa mga or data sa kada nodes, no? So full copy of master database, full copy of master database, full copy of master database. So high availability of data. Okay, so kana siya. Okay, so mo na mahitabo. So whenever the master database fail, and also the second node fail due to failure of storage or storage failure, and the other one also, the third one will also fail due to network usage, the transaction can still be completed because ang isa is available gihapon. And remember, the high availability, it makes a redundant copy of master database, no? So kaning mga nodes diri na nagdala ra gyapon na sa full copy of master database, no? So high availability. So that's it. For high availability, it is ideal for mission critical database systems, no? Kay bisan asa ang mag-fail ato, basta kay nalay isa ka buk mabilin sa node, no? Nalay isa ka buk mabilin sa node, then all data are available. So that's why we call it high availability, no? Okay, so that's it. So that's the concept of distributed databases. So I hope na ayun na learn, and later on maghatag ko og another video for the demonstration on how to configure high availability database. Okay.